So let's now move on to the next data structure that we have, which is a queue. Now this queue is nothing but what we call as maybe a line. Observe this. Suppose say this is some ticket counter, right? Now the show hasn't, the counter hasn't opened as yet. Now what happens is, say there is this first person who comes in. This person is waiting in the queue. The next person who comes in joins at the end of the queue. The third person that comes in will also join behind this person, the third person in the queue. Now, as soon as this window opens, as soon as this counter opens, the person who came in first will get the service and then move. And any person who is coming in the end will always keep joining at the end of this particular queue. So over here, you can say every person who came in first will get the service first. So this is FIFO processing, first in, first out. So queue is a data structure which uses FIFO processing. So over here, any person joining the queue or any data that is joining the queue will join from the end, and anyone moving out of the queue will move from the front of this particular queue. Now what I'm required to do is I'm required to implement this concept of a queue, that is this FIFO operation, say using an array. That is going to be the first part. Now just observe this, what I plan to do, or how do I plan to do this. Say suppose this is an array. Now, if I have this array of whatever the size, I want this array to behave like a queue. Now understand, when I say behave like a queue, so I put it like this, that I'll be adding the value from the end or the tail of the queue, and I'll be removing the value from the front or the head of the queue. So that is what is the plan, right? So that is what we will be doing. But just like what we did with say stacks, we said that just an array cannot behave like a stack. Similarly, if I just want this array to behave like a queue, it's not going to work. So the way we had that pointer called top for working with an array, I'm going to have two pointers. One is front and the other one is rear to work with this particular queue. The aim of this front pointer is that it will always keep pointing to the head, or you can say the first value into the queue. And this pointer rear or R will keep pointing to the last value or the tail of the queue. So now just observe this. See, when I create an initial queue, now obviously this is an array with whatever the index, right? So this is it. So this is n is equal to 5. So for this array to behave like a queue, I'm going to use this variable called f, which would be initialized to -1, and r, which would be initialized to -1. Initially, to indicate that the queue is empty, both these variables would be initialized to -1. Then later on, as we go ahead, f or front will keep pointing to the first value in the queue, and rear will always keep pointing to the last value in the queue. So that is how it is going to work. Now just look at this part. Now let me just get started here. Now suppose this was the queue, please. So over here, front is -1 and rear is -1. Now if you ask me to insert the first value inside the queue, what I'll do is I'll increment front and I increment rear. So front will be initialized, incremented by 1. So from -1, it becomes 0. Rear will also be incremented by 1. So that will also become 0. And then I'll push whatever the value, say 9. See, when I have added just the first value, in that case, both front and rear will keep pointing to the same index. Now just observe this, what has happened. So initially I had this queue, which was empty. Front and rear both were -1, indicating that the queue is empty. Now, when I wanted to push the first value, the front comes over here, the rear comes over here, and the value goes here. Because the queue now contains just one value, both front and rear are pointing to the same index. But now if I want to add another value to this queue, what I'll do is I'll increment R. So R gets incremented here. So this R is gone and the value comes over here. If I want to add another value into the queue, I'll increment R. The way I was incrementing top over here, I'll keep incrementing R, and my next value comes over here. See, understand, when I'm adding a value into the queue, I don't have to move that front pointer at all, because anything that gets added is getting added at the tail of the queue. So the front doesn't change. So what happens is front will keep pointing here and rear will go over here. Now, suppose similarly, if I want to delete a value from the queue, see for us, queue starts at front and ends at rear. If I want to delete a value, what I need to do is I want to delete 9. So what I'll do is I'll return the value from front, and to delete this, all I'll do is I'll increment front. So over here, front has been incremented. So front has gone, say from 0, 1, 2, 3, 4. These are the indexes 0, 1, 2, 3, 4. Right? So front has gone from index 0 to index 1. What did I tell you? For us, the queue starts at 0 and queue starts at front and ends at rear. Here front is 0 and rear is 2. Here front is 1. Here front is 1 and rear is 2. So queue starts at front and ends at rear. So all we need to do is whenever we are adding a value into the queue, we will just increment R and add the value. Whenever we are deleting a value from the queue, all we need to do is we need to increment front. What is a queue? A queue is a data structure that uses FIFO processing. First in, first out. The data that comes in first will always go out first for its processing. Is this understood, please? Now, we are required to implement this with the help of a program. So now again, we have a program over here. Write a program to implement the following operations on a queue. So now I'm required to perform the following operations. What are they? Add, delete, and display. Add a value to the queue, delete a value from the queue, and display the value. So this is what we are required to do. Now observe this. How do we start? Similar to what we've been doing so far. I'll first get started here. So to create a queue, okay, the initial part, the header files and all remain the same. I need an array and 2 pointers front and rear. So what do I do here is I create this structure which has 2 variables f and r, which are going to behave like the front and the rear. And I've created this array queue, which is again of the size 100. Needless to say, my program will not work for more than 100 values. Now, when I create this variable s of this structure type, what does that s looks like? Now, this is what s looks like. So over here, I want this array and these 2 variables to work together as a single data unit. That is why I've created a structure variable. So whenever I now want to refer to this array, I'll write s dot q. If I want to refer to front, I'll write s dot f. If I want to refer to rear, I'll write s dot r. So this is how I've created this structure variable. Now, the next thing is I've declared 3 functions: add, delete, and display. Add function will add the value into the queue. Delete function will delete the value into the from the queue, and display will then display the queue. So now that we are through with the initial part, we will first go to the main function. The flow of the main function remains pretty much identical to what we did with stacks. Please observe this. Now to start with, again, I've declared 2 variables, choice and option, which I'm going to use with my do while loops. Now, I've initialized front to -1 and rear to -1. Whenever a queue is empty, front and rear, both these variables would have these values -1. Just a reminder, why -1? The starting index of an array is always 0. So I've set it to -1 so that when I increment it for the first time, I get the index 0, which is the first memory location inside that array. Now, as the previous program, I want this program to run in a cyclic fashion. So again, I have written a do while loop like this. So this program again will keep moving in a cyclic fashion till at a stage user comes and hits a key apart from Y. So again, a menu driven code. I've displayed this menu. 1 is add, 2 is delete, and 3 is display. I'm asking user for the option. Whatever is the option that the user gives me, say 1, 2, or 3, all that gets stored in this variable called option. Now, because this variable option can again take 3 values, say 1, 2, and 3, what I've done over here is, I've used 3 cases. So if switch 1, understand this, if the value of this option is 1, in that case, it goes to case 1. It goes to case 1, which will perform the operation of addition. Case 2, operation deletion. If option is 3, case 3, operation is display. If the user by mistake enters a value anything apart from 1, 2, and 3, it will print default option. Again, if you see, main is just regulating, or main is just controlling this program, but it does not perform any operation as such on its own. Now, once the respective case is executed, 1, 2, or 3, I'll ask the user if the user wants to continue. If the user, whatever is the input that the user is giving, the character goes to this variable choice. If the user has hit Y, be it uppercase or be it lowercase, I'm okay with this. Then if this user has hit say Y, then this do while loop continues. If the user hits any key apart from Y, this loop will terminate. So this is how this main function is going to control the flow of this program. Let's now move towards the operations that we need to perform, the functions that will perform these operations for us. Let us first go to this add function. Now observe this. How is this add function going to work for us? Now don't look at those diagrams. I'm going to write this add functions. See, working with queues, always remember that the programs or the functions are similar, or functions are pretty straightforward, but these functions generally have an exception. And most students, while writing the code, they forget to take care of those exceptions. So you need to understand how to take care of those exceptions, right? Let us first try and understand over here. Now look at the different possible scenarios, right? See, whenever we are working with a queue, always remember, front will always keep pointing to the head of the queue or the first value, and rear will always keep pointing to the last value. Now, there could be 2 values, there could be 3 values, there could be 4 values, and so on. I just want you all to pay special attention to a couple of cases. Please observe this. This one. When the queue is empty, both front and rear are always -1. If there is only one value in the queue, front and rear will have the same value, because obviously they'll keep pointing to the same index. Also, observe this. Suppose, as you see in this example, there are 5 values. Suppose if the length of the queue is 5. In that case, if this rear pointer points to the last index, that means the queue is full. Now, when will rear point to the last index? The last index is occupied. That is where rear will point to the last index, and that is where we'll say that the queue is full. So 3 cases. How do we identify that the queue is empty? Front and rear are both -1. How do I know that the queue has only one value? Why does it matter? We'll talk about that shortly. How do I know that the queue has only one value? If the value of front and rear are the same, that means queue has only one value. If rear points to the last index, that means the queue is full, right? Okay. Now with this little idea, let us now get started with the program. Now understand this add function. Now, if I'm a function and I'm expected to add a value into the queue, what I'll do is I'll first check whether the queue is full or not. If the queue is full, I'll generate an error straight away saying that the queue is full. But if the queue is not full, then I need to do something and add the value into the queue. Now, just observe this, please. Let me just draw it like this. Suppose this is the queue that I have. I'm going with n as 5. So for simplicity, I've gone with n as 5. So currently the indexes are 0, 1, 2, 3, 4, right? Suppose this is a queue, right? Needless to say, the value of this variable f is -1. The value of this variable r is -1 initially to mark that the queue is empty. Okay, let me get started with the function. When I start with this function, I'll first check whether the queue is full or not. How do I check? I'll check if the value of this rear is equal to n-1. If it refers to the last index, that means the queue is full. Now, please look at this case. Suppose this was the case. The value of r is 4. If there are n values, in this case, there are 5 values. So if n is 5, the last index is 4, n-1 is 4, 4 is equal to 4 is true. I'll say queue overflow. So if you look at the last diagram, you will be able to understand what is the case that will indicate that the queue is full. If my rear pointer has the value of the last index, that means the queue is full. But let's look at the different possible scenarios, right? Let me just talk about this. Now, please look at this example. See, suppose over here, I'll again start. The value of rear is 0, and n minus 1. If there are 5 values, the last index is 4. 0 is equal to 4 is false. If this is false, that means the queue is not full. If the queue is not full, I'll come to this else part. And in this else part, I'll now think about trying to add the value into the queue. Now observe this. What happens over here? Now over here, I'll ask the user for the value. Enter the value to be added. Suppose the value given to me by the user is 23. So this value 23 needs to be added into the queue, right? Now, how do I add the value to the queue? See, look at this case. Over here, this front is index 0 and rear is index 0. If a new value is getting added into the queue, I need to increment this rear pointer. So s dot r plus plus. So going by this example that you see, if r was 0, it becomes 1. So rear now becomes 1. That means it points to the next memory location. At index rear, in this array queue, I'll copy the value of x. That is how this 23 got added to this queue. So if you see, this was the scenario, you will just increment r, and whatever is the new value that r gives me, at that index, I'll insert the value. This is similar to top. What did we do with the stack? We just incremented top, and whichever was the new memory location which is pointed to by top, that is where we inserted the value. I've done exactly the same thing, right? Now, I just spoke about certain exceptions. See, actually speaking, this code is good enough for me to add the value into the queue. Now, this is the exception that I'm talking about. Now, please understand what exactly is this. Now, look at this. Just now, when I added the value over here, front was 0, say, and rear was 0. Then when I wanted to add value 23, I incremented rear and I've got this value 23 here. See, when I'm adding a value at the end of this particular queue, only the rear pointer will move. I'm not required to touch the front pointer at all. Now, after this, suppose if after this, if I've after inserting 23, suppose if I'm inserting this value, say 56, what do? Rear was 1. I again increment rear over here, and I have inserted the value. I have to just keep incrementing rear and keep adding the values. I'm not required to touch front pointer at all. See, front was 0 here, front was 0 here, front was 0 here. Whenever I'm adding a value, I'm not required to touch the value of this front at all. But please look at this case, the one which I've drawn. Suppose currently the stack is empty. Sorry, currently the queue is empty. You wanted me to add this value 23. So what did I do? I incremented rear over here. So when I increment rear, observe what's happening. When I increment rear, the rear which was -1 has now become 0. At index r, this statement, at index r in this queue, I'll add the value. Suppose the value added was, say, 23. See, generally speaking, while adding a value, all I need to do is I need to just increment the rear pointer. But understand, now that the value that I've added is just the first value, won't I be required to set the front pointer as well? I just can't assume that, okay, front has become 0 automatically. Now, how did front become 0? Whenever I'm inserting the value, if it is the very first value which is getting added into the queue, I need to set the front pointer. Now, how do I know that this value that I've added is the first value? If the value that I've added is the first value, very first value, the value of rear will be 0. So that is exactly what I'm checking over here. If after performing this insertion, if the value of rear is 0, that means this was the very first value that I've inserted. That is why I'll increment front as well. So it sets the front pointer. So if some of you, if you've been wondering how this front became 0, when I insert the first value, this part of the code will get executed and it will increment the front pointer. So now if I go through this this particular code, if the queue is full, you give an error. If not, you perform this insertion operation. After you've performed the insertion operation, you just check whether the value added was the very first value. If yes, you increment the front pointer. Otherwise, while adding a value into the queue, you just need to increment the rear pointer. You need not increment the front pointer at all. You need not touch the front pointer at all. So that was your add function. Now this is your delete function. Now this is where we'll try and understand how to delete a value from the queue. Okay. Now, like the previous case, we will be using certain examples, but I want you all to understand certain conditions. See, first of all, before I delete a value from the queue, I need to first check whether the queue is empty or not. By now, I guess it's very obvious for you. If I want to check whether the queue is empty or not, I need to check the values of front and rear. If front is -1 or rear is -1, the queue is empty, right? Either of the pointers you can check. You need not check both the pointers. Either of the pointers, if you check, that is good enough for you. So that is one case. Now just observe this. Suppose, look, please look at this case. Suppose if you are deleting the value, if you want to delete this value 12, all you will do is you will increment front pointer. So I've just incremented front. So front goes from 0 to 1. Now this value, whatever is the value here, this value is as good as gone. Now, why is this value gone? Because all I need to do is I need to increment front. For me, the queue starts at front and ends at rear. Earlier, the queue was from index 0 to index 4. Now the queue is from index 1 to index 4. So whenever you are deleting a value, suppose from over here, I want to delete 23. What I'll do is I'll just increment front. So F, which is 1, now becomes 2. So this value is as good as gone for us. Now, if you see, whenever I'm incrementing a value, whenever I have to delete a value, I'll just increment front. I'm not required to touch the rear pointer at all. Just increment front and your job is done. This is similar to pop. So two cases we've understood. If I want to understand whether the queue is empty or not, I look at the front and the rear pointer. And whenever I have to delete a value from the queue, in that case, I just need to increment the front pointer. I need not touch the rear pointer at all. But guys, please look at this case. Suppose I have this queue, which has say only one value. Say 9. So obviously front would be here and rear would also be here. When there is a single value in the queue, that is where the front and rear will always have the same value, whatever is the index. So front and rear are the same. Now observe this. If you are asking me to delete, now I'm going to use a special condition, this one. Now I'm just discussing it and then I'll go to the code. So before I actually delete, I'll check if front and rear are the same. See, observe this. Look at this case. Over here, there were more than one value. So front and rear are not the same. Front and rear are not the same. Front and rear are not the same. So whenever you have multiple values in the queue, front and rear will never have the same values. If front and rear have the same values, that means that there is exactly one value in the queue. If there is only one value in the queue, and if I'm deleting it, won't that mean that the queue is now going to be empty? And if the queue is going to be empty, I need to reset both front and rear to -1. So understand, while deleting the values, I need to change only the front pointer, but only for this exception where there is just one single value in the queue. While deleting it, I need to reset both front and rear pointers so that the queue becomes empty. So these are the different possible cases. Now observe what is my flow in the code and how exactly is this working? How are we covering all possible cases? So starting with this queue, I first check whether front is -1. You could have checked rear as well. If this is true, I'll say queue under flow. That means the queue is not, the queue is empty. But let's take this example. Suppose this one, say front was 0. Then what happens is 0 is equal to -1 is false. So I'll come over here. Now front is 0. What I'll do is I'll return the value at that index. So from this array called Q, say suppose if front is 0, whatever is the value at index 0, like in our example, the value is 12. This value is 12. I'll return that value which goes to this variable X. Then I'll say value deleted is, suppose the value was 12, so it will display that value. So now that I've displayed that value, which is deleted, I now need to make the necessary changes. I will check, is the value of front same as rear? Now this I'm doing before deletion, right? Before deletion. So if this is true, I'll reset both front and rear to -1. So if you look at this in our example, only in this case where front is 1 and rear is 1. So this would be true. 1 is equal to 1 would be true. I'll reset both the pointers. That means the only remaining value from the queue is gone and the queue is not, and the queue is now empty. But suppose say it was say this case, right? So where front is 2 and rear is 4. So this would have been 2 is equal to 4 is false. If this is false, I'll come over here. I'll just increment the front pointer. So if front was 2, the front will now become 3. This value is now gone. So this is what it is. So please remember this exception. This condition will be true only while deleting the only or the single or the last value remaining in the queue. So that is what is your delete operation. Okay. So now we move on to the last function over here, which is your display function. Now please understand this. See, obviously, before I display a value, I need to check whether the queue is empty. If the queue is empty, I can check either of these variables and say that the queue is empty. But if the queue is not empty, what do I do? Please remember, the queue starts at front and ends at rear. So suppose if this is the case, I will write a for loop which starts at F and ends at R. The loop has to start at F and ends at R. I don't care whether F is at 0 or F is 1 or F is 2. Always remember, I'm not telling you that like stack queue will always start at index 0. No. The queue will always start at front and end at rear. Because what happens is, if there was this first value at index 0, if this value has been deleted, then actually your queue is starting from index 1. So I just need to write a for loop which will start at front and end at rear. So that is what we are required to do. Now observe this. See over here, I need to start at front and then I'll keep going this way and I'll start displaying the array. Now please look at this. In my display function, I'll first check whether front is -1. If yes, queue is empty. But suppose, let's take up an example. Suppose if you look at this second figure, this one, I'm talking of this one. So over here, front is -1 and rear is 4. So what is happening is, sorry, I'll go here. So front is 1, right? 1 is equal to -1 is false. I go to this else part. In this else part, I'm writing a for loop which starts at front and goes till rear. I is equal to s dot f. Front is 1. What is the value of rear that we've got over here? Rear is, say, suppose 4. So this will go to 4. So starting with I as 1, going till 4, I'll display the values from the queue. So over here, this for loop is pretty much displaying the array starting at index front and ending at index rear. So this is how we will display this particular queue, and this is how we'll implement a queue using an array.